In this recording, we're going to look at combinations. And a combination, as it defines it on your sheet, is a subset of elements where order does not matter. That's the key right there. So not an arrangement, that's a permutation. So let's look at a couple examples here. Janine would like to select 3 DVDs out of her collection of 22. She doesn't care about the order. She just wants to know how many sets or groups can she make. Okay? So combinations, the key concept of combinations are things where order doesn't matter, like committees, groups, sets. So we're just going to do 22, choose 3. That's the way we think about it. 22, choose 3. So let's grab our calculator. Let's figure out what 22 choose. So you're going to put in a 22. As you probably imagine, you're going to go to math, go over to probability. It's the third choice down. 22, choose 3 is maybe not as big as you would have thought. Order doesn't matter, so it's not quite as big as if we had arranged those 22 CDs or DVDs 3 at a time. So we'll jot down that there's 1,540 sets. I'd like you to work on example number 9, involving Jerry's outfits, for your check for understanding. You can do that now, or you can do it after you finish the recording. We're going to move on to talking about probability using and or in real simple examples. Okay? So in general, if I asked you for a probability involving the word and, let's think about that intuitively. I'm going to roll a die. There's 6 possibilities. So the probability of getting a 6 on that would be like 1 out of 6, right? Okay. If I then flip a coin and I want them both to happen, hopefully you should realize that that's going to decrease the probability overall. So what I'm going to do is multiply by a half the probability of getting ahead. If I were to add these fractions, that would increase 1/6 quite a bit. Okay? So the probability of getting a 6 and ahead is the product of those, it's 12th. Okay? So and indicates multiplication. And is multiplication. All right? Next, say I wanted an or. I'm going to roll a die. Again, I've got 1/6 of the time I'm going to get a 6. If I say to you, okay, I win if I get a 6 or ahead, well, we still have the probability of getting ahead, which is a half. But if I get either one of these, I've increased my probability, and the way to increase my probability is to add the fractions. Okay, so if I add the fractions, I need a common denominator. I have to change 1/6. I leave 1/6. I have to change 1/2 into 3/6. Of course, that's 4/6 or 2/3. And obviously 2/3 is quite a bit bigger than 1/12. Okay? So the keyword or indicates you're going to add the probabilities. All right, I'm going to have you work on example number 10 on your own after you work out number 11 with the video. Okay, this is a complicated question here. A college faculty consists of 42 professors from the College of Arts and Sciences, 37 professors from the College of Engineering. How many 5 different member committees, so committees, order doesn't matter, that's what you should be thinking about, can be formed from the faculty? So, the first thing we have to establish is, well, how many members of the faculty are there? We've got 42 and 37, so altogether that looks like 79 total professors. Let's write that down. 79 professors. And I want, of those 79, to choose 5. So it's a 79, choose 5. And we've expressed that with combination notation is 79 C 5. Okay? Grab your calculator, put in that 79C5 and see what you get. The number I got was 22,537,515 different committees. Okay, the second part of this question is a little more complicated because there's restrictions on it. Okay, I'd like you to read through this question, play the video after you've had a handle on it. Okay, in this one, I need 5 member committees, but there's some restrictions. I need 3 professors from the arts and sciences. So what that looks like to me is I've got 42 to choose from, and I want 3. Then I need 2 professors from the College of Engineering, of which there are 37. So it's a 37, choose 2. Fine. Keyword here, and. Okay. Think about above. Did we multiply or did we add when we wanted and? Okay? And indicates we multiply. So you figure out those 2 numbers independently. The numbers I got were 11,480 times 666, and you're going to multiply those together for a grand total of 7,645,680 committees. I'd like you to work on number 10 on your own and bring your answer and your questions to class. Thanks for watching.